Hello, my name is Uwe Brodmann, and I'm the CEO of INCHRON. This presentation will give you an impression about the return on investment that we generate for our customers in the development of robust, efficient, and compliant architectures. This presentation is the short form of a longer presentation that we are happy to provide you as well, but in this short form we will give you a short overview of how we create value in the development of embedded architectures. A brief overview on the company. The company was founded in 2003 based on research that started in 1996 at the University of Erlangen-Nuremberg. Over the years, we have won a lot of customers with a focus on the automotive industry, but now moving into other areas like aerospace and defense and medical and telecommunication as well. Our strong partners are IBM and Electrobit, and we are members in organizations like AUTOSAR and TIMO. But let's now take a look at the challenges that you are facing and the value we are providing. It all starts in the concept phase of a project, where you have to look at your design goals that are, of course, functional, but that are the robustness and the efficiency of your system as well as being compliant to standards like SPICE or ISO standards, where these parameters are predominantly driven by mechanics and algorithms when it comes to the functional aspects, by the systems architecture consisting of the hardware and the software side when it comes to questions of robustness and efficiencies, and by processes, methodologies, and tools when it comes to compliance. Now let's take a look at cost and price. If we look at the mechanics, obviously the impact of mechanics on the cost and price of your systems are very high. Algorithms are usually fairly low, except for exceptional situations maybe where you have to buy very special algorithms from some specialist, but usually the cost for algorithms is not that high. The systems architecture, consisting of the hardware and the software side again, is very expensive and has an impact on the cost and price of your whole product. Processes, methodologies, and tools obviously have a certain price in the development phase, but then to set them up is something that is not accounted for one project only, but has to be done throughout the company. Now, once you have set up your concept in the bidding phase as a supplier, you are now looking at the situation where if you go in with a low price, the probability to win the project is going to be high. Unfortunately, the probability to make this a profitable project is going to be low. So the challenge is to find a system architecture that gets the high probability to win the project and combine it with a high probability to make it profitable. Because when we get into execution, typically there are changes. And if we look at the potential cost of changes, if you have to change the mechanics, this is going to be very expensive. Algorithms usually very high, but again, we had customers who said, well, but we have this very special algorithm, but usually to change an algorithm is not that expensive. To change a systems architecture, however, can be really expensive, and when it comes to changing processes, methodologies, and tools, that can be expensive as well. But again, this is usually done for the whole company or a business unit and not for a single project. Now, what is the project? What does the project look like from an economical point of view over time? Well, you have your budget, and usually the cost builds up according to budget, and we're looking here at a project that is supposed to take 24 months for the software development. Unfortunately, in quite a few cases, you have budget overruns. And very unfortunately, in quite a few projects, there are delays. And these delays have an impact on cost, time, and obviously on capacities that were supposed to be used in other projects already. Now, as the architecture has such a major impact on the risk of delay and project overrun, our statement is we make sure it works, we make sure you don't run into these risks. Now let's take a look at how we do that. And again, this is the short version. We are happy to give you more insight into the background of how we get to these conclusions, but that will take a little bit more time, so here's the short version. If we take a look at these aspects and parameters, again, as we said, we focus on the systems architecture. Now, if we look at what is driving the risk of budget overruns and delays, we, together with our customers, have come to the conclusion that it is the combination of the level of complexity of a system and the level of novelty that this kind of complexity has for a development team. So for example, if a development team has done something multiple times and it's a very low complexity system, the risk of things going wrong is going to be very low. The opposite, if you have a very high level of complexity and the team has never done that before, the risk of running into delays and budget overruns is very high, because over time things will change, mistakes will pop up, and in a project that has a budget of 3 million euros or dollars, we have come to a calculation where at a minimum or at a medium risk, we're talking about $200,000 or euros that you have to add to every project of that category if it's just a medium risk. Once you get into a higher risk, it's a multiple of these 200,000, so we end up at something like 600, maybe 700,000 that you really have to add on in risk for delays and cost. Now, how do we solve that? With the INCHRON solutions, and I'm not talking about the technical background in this presentation, please have a look at other materials on how we do that, but what we do is we can check the robustness and scalability of your system very early in concept phase already, and we can then check that robustness and scalability throughout the whole process. And what the impact is, and that's what we have gone through with multiple customers, is that we reduce the risk of budget overruns and of delays substantially. We bring it down by 50%. Now, if we do the math again, we can do an early investigation of robustness and scalability through simulation and what-if analysis. The amount of time that has to be invested obviously depends on the complexity or the risk level of your system. So if it's a small, not really complex system, we can do that in a few days, well, maybe 7, maybe 10. The more complex the system gets, the more time it takes us, or it takes our customers, to set up the models and to do the simulation. But if you do the math and see that within 30 days, you can reduce your risk by 300,000, whether it's euro or dollar. That is a massive return on investment. Now that is one side of the story. Early investigations of robustness of an architecture. The second is to look at the processes and activities in the development process. Well, changes occur, whether they are driven by customers and change requests or additional features, or whether you find out that you have run into an error. These changes occur. Now, here's your rework process. Your steps of requirements changing, of changing the code or an operating system priority, of validating, verifying that, integrating it, talking to your customer about it, this is the process. Well, but then sometimes you need rework, and you do another iteration. And if things go wrong, you may need a second time of rework and a third iteration. And this is what we avoid, because we do all these what-if analyses within minutes through our system and the simulation, and we find the bugs and the errors very fast before we go into that iteration. Now, what does that mean in dollars or euros? With our customers, we have come to the conclusion that in most cases, something like 12 days are taken to walk through the different steps in this iteration. So from change requirements to changing code, verifying that, doing the integration, the validation, and the customer interaction. Obviously, this is an average number, but it has been validated by a lot of customers that we talked about. Now, let's take a look at these different iterations I was talking about. And remember, an iteration takes 12 days. Now, if we look at 30 changes or change requests that have an impact on the dynamic timing behavior that we want to take into account here, this means in 50% of the cases, things work out in the first iteration. You know, you do it, it works. Unfortunately, there are cases where you have to do a rework once, but rework once means 2 iterations. And then, as we said, you know, in some cases, you need rework twice. And it happens, I don't know, maybe not often, but it does, that you have to do 3 works, and then you run into 4 iterations. With INCHRON, you avoid that. Maybe not completely. Maybe there is a case where you have to do 1 rework again. It happens rarely, but let's take it into account. But what you end up with is saving 17 iterations. And if you multiply that by 12, you end up with 204 man days, and that is money, and that is capacity that you may not even have. So this is the combination of the return on investment through reducing risk by having an architecture that is robust right from the beginning, and by reducing the number of iterations that you maybe have even taken into account in your budget, but that you can save by using INCHRON solutions for the simulation and analysis of your system architecture. Now, as I said, this was the very short version of the ROI calculation. There is a longer version available as well, and there is more information available about the technical background on how we all do that. So please contact INCHRON or IBM for more information and to calculate your ROI in your project with your numbers for you. Thank you very much for attending this. All the best, and bye-bye.